You can see we've got gravity, and that's just pulling our dribble back down onto the surface so it doesn't, just float around. We've got wind, and in this case wind has just been used just to give a kind of random effect to our dribbles. You notice they're not running just straight down. You'll see they're actually running down and they've got kinks in them and so on. If I actually turn on the display of space warps and grab the wind force, you can see we've got a value here of 0.7, but if I change it to 2, you can see the dribble shape has changed. If I change it to 0, you can see it's now falling straight down. So this turbulence is actually used in this case just to give our dribbles a nice sort of random factor, because the metal surface is meant to be pitted and it's meant to be rusted, and the dribble wouldn't run down in a straight line. It'd follow a sort of crooked path. So that's what I've actually done in this case. I've actually just used this turbulence to give that kind of effect. We've got drag, doing the usual thing, stopping our particles going too fast. Collision, this is just a simple collision just to keep the particles on the surface of a cube. And then we've got spawn by travel, which, as I said, is creating these little spheres which are being left behind, or emitting particle. If I go down here and change this to dots, you'll see that we've got this seed at the tip, and it comes down, and you can see that as it travels along. Actually, it would be this one. We just need to change this to geometry. Let me just do that. There we go. So this is basically what I would call a sort of dribble seed. It just it goes along the surface, and it follows this irregular path, and you can see that at the end it actually dies. We get rid of it. We don't really use it. Once this has actually gone down and made its dribble, let's just change this to dots so it makes it a little less obvious. We'll just change this one to geometry again. There you go. So it leaves these dribbles behind, and then after a certain period of time, you can see if we go in here, we've got random rotation, which I've just described to just break up the surface. We've got material dynamic, and this is this hot material that we saw at the beginning of this chapter. That just gives us this sort of molten metal effect, which cools down over time. And then we've got an age test, and when the particles reach an age of 19, that means they've cooled completely. And at that point, what I wanted to do was I wanted to change materials, and I wanted to have a sort of nice mercury-looking material, dull mercury, and that's what happens here. It gets passed on to another event where it has this mercurial material used instead. And you can see I've got the age set to 19, and you can see I've got this delete set to an age of 20. So in other words, none of the particles never actually get deleted, because before they reach 20 and get deleted, they always get saved, as it were, by the bell, or in this case the age test, and they get sent on to the next event where they have this mercurial material added to them, which gives us this sort of metal effect once they've cooled down from being molten. And that's it really. All of these elements go together, and in comp, I think the only thing I really did in comp was obviously take the bright colors that you see in this. I think I rendered out the laser separately. I rendered out the spark separately. The actual surface with the etching and the molten metal dribbling down it, that was all rendered together. That was all rendered as one pass, as it were. And then I comped on the sparks, I comped on the laser, and the only reason for having the sparks and the laser separate is that you've got more control over exactly how bright they are, and then you can blur them and add them, and that gives you a nice sort of glow effect. And I think the only other thing I did was I may have rendered a light at the tip of the laser. If I show you lights turned on, you can see there is actually a light here, and I'll just close down the particle view. If we go to environment, you'll see I've got a volume light set up, and it's actually using this light here. So this light was just used to create a volume glow, and again that was added on in comp, and that was just to give a little bit more of a sort of feeling of heat to the whole scene. So there you go. It's a pretty cool effect. It's not amazing, I'm not saying it's a fantastic effect, but it's got some interesting principles in there. The idea of using these animated materials to do these displacements. You've got sparks in there. You've got this laser, which is using an animated spline by using linked X forms. And then you've got these dribbles, which are running down the surface. You can see I've kind of cheated by using very simple spheres to create the impression that you've got this sort of smooth run of metal. As I said, you don't have to cheat. You could use blob mesh if you wanted to get up close and actually see much closer to that metal dribble. You could use a blob mesh on there, and then that would produce a much smoother surface. But as I said, because of the distance from which we're actually viewing this effect, that really wasn't necessary, and therefore I went with a quicker option, which was rendering these spheres. And at the end of the day, in particles, you've got to always bear that in mind. Try and take the simplest route possible, both in terms of producing the particles and in terms of rendering the particles. Don't get overcomplicated. Don't have 9 million particles when you can get away with 1 million or 500,000 or whatever. Don't use 9 million particles when you can get away with 100,000 particles mapped to look like 9 million particles. Cheat as much as you can, because at the end of the day, that's what particles are about. They're cheating. They're not dynamic. They're not real particles. They're not real dust. They're not real atoms. They really are just a simulation, and they're just there to approximate something that we see in the real world. Okay, so let's move on now to our next effect, which is again, it's quite a useful effect. In certain circumstances, you might have somebody walking, and you may want to have them produce, rain splashes or dust splashes. And you can do the same kind of thing with cars as well when they're driving through a sort of dusty or wet environment. You want this sort of automatic system for splashing and or producing dust puffs and so on. So let's go on now and have a look at our automatic dust system.